Diffraction is one of the characteristics of the light waves. Okay, bending of waves, light waves around the sharp edges by obstacles like doors, windows, buildings, etc. So the bending character of light is called diffraction. For example, in a room, okay, you have closed the room, it has the windows and the doors like that. When you put the light into the room, okay, so if you are in outside the room, you can see that the light rays, the gap between the doors and the windows, etc., like that. So the bending character of light is possible to flow in the other ways. Okay, so that is called diffraction. Okay, so where is it possible means at corner only. Okay, so light go to the straight line. If you have placed any obstacle means it will change its path. So the bending of light character is called diffraction. Okay, so using this concept we can producing that interference also. Interference means the two waves are at a immediate point which may be the maximum or minimum in the intensities. That is called constructive or destructive interference. Okay, so next we will see the topic of diffraction at a single slit. So this is the 5 mark question. Okay, so this diagram shows that diffraction we can form in a single slit. So this is a single slit. It gap with this say A. S is the source of light. It can produce in the light waves. L1, L2 are the two convex lenses. They are placed after that source and after the slits. Then you place the screen which is parallel to the slit. Okay. So first the source can emit the light rays. It goes falling on the first convex lens. Then make it parallel, which is falling towards the slit of the light. Okay. So that the diffracted beams here it falls on the screen, at the O. Okay. So that the center of slit, the straight line is falling at the O here. So the straight line to the point C, which is center of the slit. Okay, which is perpendicular to the plane of the slit, which means the center of screen at O. Okay. Next, consider any point on the screen, say P. Okay. Now we see that all the light from the point P. So all the light from the point P from the different points on the slit make an angle theta with the normal to CO, which means see the first light, the source of light emits the light waves. So parallel to the slit, it will be falling on the center O of the screen. Next, it makes a diffraction. So the bending character of light takes place here. This is called diffraction. So the diffraction rays are parallel to each other and falling to another lens which are kept in the after the slit. Okay, so which makes the converging region at a point P. So due to the interference of two light, the point will become maximum or minimum. Okay, so all the light rays are coming from the different points on the slit interfere at a point P. Okay, or any other point of screen to give that is an intensities or constructive or destructive intensities. Okay, so the point P is shown here is maybe the central maxima of the spread out due to the diffraction. Okay, now we have to come from the point P. Okay, maybe the various minima or maxima. Okay, to find the minimum maximum of this at the point P of the light waves, so we have some idea is following here. So the slit with this A is there. Okay, so we have to the condition for the point P is minima. We have to divide the slit into the smaller even numbers. Okay, so for example, A is there. You divide A by 2 means the point P will be that do that minimum. For getting the maximum intensities, we have to divide the slit with the odd numbers. Okay, so let's see what is the condition for the P to be the maximum or minimum. Okay, first we see that what is the condition for the point P be the minimum. Okay, so I did told the width will be divided by in the even parts to get the minimum minimum intensity at the point P. That is called destructive interference. Okay, so AB is the width of the slit. Say small a is the value. Okay, so this is a normal line to draw the like this to make the interference at the point P here. So what is the angle here? Theta here. So AB, this is small a, the angle is theta. Okay, so now we have to considering this triangle to find out the value of that condition for that minimum. Okay, How can we get that interference at the point P means, see here the light waves are travel at a point AB, okay, but from the C it makes a small path difference between A and C. At the same time from the B the waves are also producing a path difference. So the path difference is can producing an interference at a point P. Okay, if the path difference not making here means, so all three rays are moving in parallel, so they won't meet each other at any point, so that there is no interference position. Okay, so the path difference is important, which makes the interference at a point P on the screen. Okay, let's see what is the condition for the first minimum at a point P on the screen. Okay, so we have to divide the slit AB. Slit AB is divided into two off, which means you have to divide it by the times of A by 2. Okay, so we give the diagram like this. So A, center point is C, this is angle theta, then full length AB is, the full length A to B is A, but our distance is A by 2, so A by 2, this is the path difference. Okay, so in this right angle triangle, what is sin theta? Sin theta equal to the formula opposite side by the hypotenuse side. So opposite side is del, is a path difference symbol, then hypotenuse side is A by 2. Okay, now interchanging these two, okay, or multiple, then only you get the del. Okay, so that del is equal to A by 2 into sin theta. Okay, so this is the condition for a path difference. Then it makes it minimum. So condition for a minimum, this path difference is equal to lambda by 2. Okay, so we write A by 2 sin theta is equal to lambda by 2. So the lambda by 2 is a path difference. Okay, so 2 get cancelled, so we get the equation A of sin theta is equal to lambda. This is for the first minimum. Similarly, we will see for the second condition for the second minimum. So we have to cut the slit into the 4 times. Okay, so we write as A by 4 parts. So the part difference will be like that, del equal to A by 2, sorry, A by 4 sin theta equal to, the condition is what, same, lambda by 2, 2 ones are 2, 2 2s are 4. Okay, so that we have the condition is what, with the 2 here, so A sin theta is equal to 2 into lambda. This is the condition for the second minimum. It is also appear on the screen. Okay, next we see what is the condition for the third minimum. So we have to cut the slit into the 6 spots, so A by 6, so that the del equal to A by 6 into sin theta. Same condition for the minimum is lambda by 2, 2 ones are 2, 2 these are 6, so that A sin theta is equal to 3 into lambda. So this is the condition for the third minimum. Okay, so like this. So finally we have to find the condition for that nth minimum. Nth means the last. Okay, so we have to cut it in the 2 end parts. So the formula of the part difference del equal to A by 2n into sin theta is equal to lambda by 2. So 2 gets cancelled. So we have A sin theta is equal to n lambda. So this is the condition for that nth minimum. Okay, so this is the way you have to find the condition for that minimums, also on the following on the screen. Okay, similarly we can find that condition for the maximum also. Okay, so for condition for the first maximum, So we have to continue in a odd number of the slits. So I write continue by a by 3. Okay. So the part difference del equal to same a by 3 into sin theta is equal to lambda by 2. Okay. So 3 brings here. So that is a into sin theta is equal to divided 3 the multiple of lambda. So put 3 by 2 into lambda. Okay. Next we see the condition for the second maxima. So you have to cut the slit into the 5 parts, so that del equal to a by 5 into sin theta, that is equal to lambda by 2. So divide 5 multiple with here, so let us a into sin theta is equal to 5 by 2 into lambda. Next condition for the third maxima. So we have to continue the 7 parts of the slit, so a by 7, then del equal to a by 7 into sin theta is equal to lambda by 2, then a sin theta is equal to 7 by lambda, 7 by 2 into lambda. Okay. Similarly for condition for the nth maximum. Okay. So nth maximum you have to cut in the parts like that. Even number means 2 is a even number, so odd make a 1 plus 2. Okay, so that a sin theta is equal to 2n plus 1 into lambda by 2. Okay, this is the condition for that nth maxima. Okay.